Hi everyone, welcome back. In today's video, we are going to talk about the second learning outcome statement from rates and returns reading. It is about calculation and interpretation of different return measures. Okay, so let's start. Firstly, what kind of returns do financial assets generate? Well, there are two sources of income. First one is periodic income. For stocks, it is called dividend income, and for bonds, it is coupon. For the secondly, it is capital gains, which is the appreciation in price of the financial securities that you have purchased. Okay, what kind of return measures that do we use to measure the return over the investment? First one is holding period return. We're going to call it HPR shortly. HPR is a single period return measure. It means it measures the return over a period of time for a single period. It can be a month or a week or a year. And it answers the question of how much you earn by purchasing and holding a financial asset for a period of time. Here you can use a formula here. P1 is the price of the security at the end of the period. P0 is the purchase price at the beginning of the investment period. And I1 is the income, dividend, or coupon payment during the investment period. In example we can see more clearly how HPR works. An investor buys a stock for $1,000 and holds it for 1 year. At the end of the year, the stock price has increased to $1,080, and the investor also received $20 in dividends during the year. What is the HPR for a year? We are going to use Formula 1 for this, and as you can see, it is 10% here. And we get it from two sources, price appreciation, firstly, this $80 increase in the price of the stock, and $20 dividend income that we have received during the period. We can also combine HPRs across time periods to find HPR over an investment period. For instance, if the investment period is 3 years, and meaning that you hold the asset for 3 years, and we have annual returns for that asset, we can combine 3 annual returns to find HPR over the 3-year investment period. Okay, here you can see the formula for that, and we are going to see it in action in the next example. An investor earns annual holding period returns of 5% in the first year, 8% in the second year, and minus 2% in the third year. What is the total holding period return over the entire 3-year investment period? We are going to use the formula here, and it is going to be 11.1%. So, what does it mean? It means for the 3-year investment period, although you earned annually 5%, 8%, and minus 2%, your overall return for 3 years is 11.1%. But as I have explained in the beginning, HPR is a single period return. It's not an average return. It's not an average annual return. We can use mean or arithmetic mean to calculate average annual return. Here is a formula for that. It is simple. These R's here are periodic returns, and T is the number of periods. Basically, you sum up the periodic returns and divide it by the number of periods. In example 3, we are giving 4 periods and 4 returns corresponding to that returns. These are our annual returns. And using the formula 2 here, we calculate mean return as 6.5%. But mean return has a limitation. It assumes the base amount at the end of each year is the same. Let's illustrate it so we can understand this limitation better. You invested $1,000 in a stock. For the first year, the stock price increased by 50%. For the second year, it decreased by 50%. How much did you earn or lose on this investment? Well, there are two ways to calculate this. First, let's start with arithmetic mean. If we calculate arithmetic mean, basically we sum 50% and subtract 50% loss from the second year from that, and divide it by 2, we end up with 0. It means that we did not lose any money. But is it true? Let's see. Using the actual returns, 50% increase in the first year and minus 50% in the second year, we can see that the ending value of investment at the end of year 2 is $750. We started with $1,000 and ended up with $750. So we actually lost $250 over 2 years. But arithmetic mean told us that we actually didn't lose or make any money. As you can see, here, arithmetic mean assumes that the base amount, which is $1,000, from year to year does not change. If we multiply $1,000 with 50%, we end up with $500. And if we multiply $1,000 in year 2 with minus 50%, which was our return in the second year, we end up with minus $500. So when we sum them up, it shows zero, meaning that we did not lose any money. However, as we saw, by using the actual returns, we actually lost money. Therefore, arithmetic mean has a limitation. Let's see it in action with another example. Assume you invested $1,000 in a stock. Using below returns, calculate annual investment value and compare it with mean return. Okay, we start with $1,000, and here are the actual returns from the previous example. And each year, using these returns, the ending investment is 1,080, 1,210, and at the end of year 4, it is $1,277. So by following these returns, we end up with $1,277 at the end of year 4. Well, we will expect the investment grow to $1,277 at the end of year 4. However, if we use arithmetic mean as we have calculated previously as 6.5%, we end up with a different number. Here you can see we are going to multiply uh, beginning investment value each year by with 6.5% and end up with $1,286 at the end of year 4, which is different than the number that we have calculated using the actual returns here. Arithmetic mean here does not consider compounding. Compounding means your investment earns returns not only on the original amount but also on the accumulated returns from the previous periods, meaning that you earn on the income that you have earned from previous periods. Not only the original amount generates returns but also the earnings during that period. To account for compounding, we should use geometric mean. And here you can see the formula. It is the multiplication product of annual periodic returns, and then we find the root of it and subtract 1 and find geometric return. Let's calculate geometric return with the same returns that we have used in the previous example. And as you can see here, it is 6.31%. Now let's compare it with arithmetic mean return. If we use arithmetic mean, which was 6.5%, and calculate annual ending investment values, we are going to end up with $1,286, which we actually calculated in the previous example. However, geometric mean gives us $1,277 at the end of year 4, which was the same amount when we used actual returns. Actual returns, these. Remember, we calculated the ending investment value by year, and at the end of the year 4, it was $1,277. So what does it tell us? It tells us that geometric mean is the correct mean to calculate average annual return to account for compounding and end up with the investment value that we would use by calculating it with actual returns. So geometric mean is always going to be less than arithmetic mean, except there's no variability in the data, meaning if the data points in the data set were the same, the geometric mean and arithmetic mean will be the same. Also keep in mind that to account for compounding, we should use geometric mean. Finally, we are going to talk about harmonic mean. Here you can see the formula. N is the number of observations and xi are the observations, individual observations, the data set. Harmonic mean should be used when the data is expressed as percentages or rates or like ratios. And the advantage of harmonic mean over arithmetic mean is that it is not heavily influenced by outliers. Outliers are the extreme data points in the data sets. In example 7, we can see it more clearly. Well, here we talk about P ratio. Let me give you a little bit of background on what P ratio is. P ratio is basically the ratio of stock price or price per share to earnings per share. It tells us how much you pay for $1 of earnings of a company. If it's 10, it means that you pay $10 in share price for $1, not in share price, sorry, but you pay $10 for $1 of earnings of the company. Here, let's calculate arithmetic and harmonic mean for this data set. And we see that arithmetic mean is 59.25 and harmonic mean is 15.7. It is normal because arithmetic mean is heavily influenced by this 200 value here, but harmonic mean gives less weight to 200. Another use for harmonic mean is cost averaging, where you uh, want to find out if you would invest a fixed amount into a stock, and, and then you would want to calculate your average cost per share. Here in this data, we have been giving three or daily data set, daily values for price per share and the investment amount, and we calculate shares bought, which is the ratio of investment to price per share. And at the end, we have invested total is $300, and we've purchased 18.33 shares. So what is the average cost per share? We can calculate it by dividing total investment, which is 300, by total shares, which is 18.33, and we can find that average cost per share is actually $16.36. If we use arithmetic mean to calculate average cost per share, it will be 20, which is misleading. But harmonic mean actually gives us the uh, correct number, which is 16.36, which we calculated by using the total investment and total shares. So harmonic mean is the correct mean to use in this case. So what is the relationship between three means? Well, if you multiply arithmetic mean by geometric mean, you are going to end up with geometric mean squared. Uh, it basically means if you have arithmetic mean and harmonic mean, you can calculate geometric mean. And harmonic mean is always going to be less than geometric mean, which is also going to be less than arithmetic mean all the time. And you should keep in mind that harmonic mean can only be used when the observations in the data are positive numbers. Previously, we have talked about the effect of outliers on the dataset and on the mean. Well, we can use trimmed mean and winsorized mean to address this problem. With trimmed mean, we remove the lowest and highest values in the dataset and calculate mean from the remaining data. With Winsorized mean, however, instead of removing the outliers, we are going to replace the lowest and highest values with the closest remaining values inside the dataset and then calculate mean from the new dataset. Let's look at an example to understand it better. Here we have been giving 6 employee salaries, and we are going to calculate arithmetic mean, trimmed mean, and winsorized mean to see which one gives us a more clear answer. With arithmetic mean, we are just going to sum all the salary here and divide it by the number of employees, and we are going to end up with $193,833. With trimmed mean, however, we are going to remove 5,000 and million from the dataset, and then we are going to calculate the mean from the middle values here, and we are going to end up with $39,500, which is the average or trimmed mean in this case. With winsorized mean, we are going to replace 5,000 and million with the closest values, which is 36,000 and 39,000. And then we are going to calculate winsorized mean, and it is 38,833. Here in this final table, we are going to see the differences between three methods. And as you can see, trimmed and winsorized mean are pretty close to each other. However, arithmetic mean is very high, which is due to the result of uh, the outlier of 1 million here. To sum up the video, we have learned about the various return sources of financial assets, holding period return, arithmetic mean, geometric mean, harmonic mean, trimmed and winsorized mean. We now know what an outlier is and which mean measure that we should use to calculate returns in a given scenario. I hope you enjoyed the video. To see more content like this, please don't forget to like and subscribe.